Hello students, welcome to today's session. So we are into yet another session of problem solving of acid radicals. So let's start with the session. Most of these questions would be more than one choice questions. Most of these are more than one choice question meant for IIT Advanced coming this year on 28th of August. So here comes the first question. This had been a question which I asked you in the previous video as an homework question, where you are being given two silver salt as sulfide and carbonate, which is to be heated. So in this particular question, what are the product being formed? Here you have to take into consideration that when you heat silver carbonate, you happen to get carbon dioxide, but in this case you would get silver. So here the beautiful thing is that silver, when treated with sulfite ion and is being heated, this in fact is acting as an oxidizing agent. This acting as a reducing agent, and this would act as an oxidizing agent. So this sulfite ion would reduce silver positive to silver by giving these two electrons, you can say it like that, and as a consequence it would itself changes into SO3, which in a way would become plus 6. So this goes from plus 1 to 0. So this is a beautiful thing which you always have to remember. This is a redox reaction, and this in fact is a non-redox reaction, because carbonate ion would not do any sort of it is not going to do any reduction of silver. So this is very important. So what options do we get in this case? The first option, they said silver sulfide and oxide are respectively formed. So this in a way is a wrong statement. Reaction 1 is a redox, yes, and reaction 2 is a non-redox, yes, it is perfectly right. Metallic silver is formed in reaction 1 is a right one. Both of these are non-redox, this is a wrong one. So the answer to this question would be B and C. And I should make it a point here. Generally it happens is that if you just would take a bit of water along with, this in fact would change into sulfuric acid. And here in this case, if a bit of water is being added, this would change into carbonic acid. So this also you should keep it in your mind. Coming on to the next problem, moving on to the next problem, what we have in this. So in this problem, what we are able to see is salt P is treated with dilute HCl and turbidity appears, which on heating disappears. So as soon as you get this turbidity viewpoint, immediately one thing should come, because we did so many questions in the last video also, that sulfite ion, thiosulfite ion, when treated with H positive, gives you sulfurous acid, thiosulfuric acid, which on heating changes to sulfur plus H2SO3. So this system would provide it a what you call that as a turbidity, and this turbidity immediately vanishes when this would change into I should say water and sulfur dioxide. So sulfur dioxide leaves out the system, so the turbidity disappears because H2SO4 got decomposed. And other way around, if you just would add silver nitrate into this, that also would give you a little idea. So what we have said, that to begin with it seems like it would be a thiosulfate ion, and then if you treat it with silver nitrate, what would happen? Silver nitrate, when treated with what you call this as thiosulfate ion, so you happen to get this viewpoint, this precipitates you would get, and which on heating would change into Ag2S, which is a black PPT. And if you add excess of thiosulfate ion, this makes a soluble clear solution, of this type. Soluble clear solution of this is a clear solution. So all these inferences are giving us the viewpoint that this must be, so white precipitate is first being formed, and this white precipitate is of Ag2S2O3, and then black is of Ag2S. And if hypo is again added, hypo means sodium thiosulfate, it makes a soluble clear solution. So the question is asking which of the following a salt P cannot be. So make it a point, you need to be very watchful. Although we got this answer, but the answer to this question would be are B, C, and D. B, C, D would not be doing the things which is being done by S2O3 2 negative. So coming on to the next problem. Oh, this again seems like a very interesting one where you have to select the correct match out of this. So you have to select the correct match. So let us do this question slowly. And so first A part is talking about sulfite ion treated with H positive. So when sulfite is being treated with H positive, you would get sulfurous acid, and which on heating gives you water plus SO2. So I could clearly see there is an option of SO2. Okay, so we may think about SO2. Moving ahead, if silver ion is treated with sulfite ion and silver ions are in excess, so if silver ion is in excess with the sulfite ion, if this is in excess, then what you would get are these precipitates. You would get these as precipitates. And as a matter of fact, if sulfite ion is in excess, then it would be a water soluble complex. If in the system this is in excess, out of the way I am telling you, so then you would have this sort of a moiety formed which is soluble, and this soluble thing get precipitated if excess of silver ions are there. Now what they have said, it is to be heated. So the point here is that if Ag2SO3 is to be heated, just like in the first question we did, decomposition of this particular compound gives you metallic silver plus SO3. SO3 can combine with water to form sulfuric acid. So that you can think about that way. So that means for the B option, we may have silver, and I think in the previous option something is different. So SO3 and sulfur. Okay, so I should rectify this particular. Here it is, they have written SO3 H2SO4, and fifth was sulfur. So this is the options which I wrote it wrongly. So that means somewhat B, the option number B and option number D would have the same sort of answers. And now we are left with Ag2S2O3. So what should we get for this? So Ag2S2O3 when heated gives you AgS and SO3. So this we have done, this we have done. Now we have to match the options. Now let us do it carefully. So in the first case, when you talk of A option, when thiosulfite ion is being heated with H positive, thiosulfite ion is being heated with H positive. I think here also this again is being, I picked the wrong slide here. So this is the right slide. So if you have this thing with you, thiosulfite ion when heated with the H positive, so I should write somewhere. So S2O3 2 negative 2H positive goes to H2S2O3, which is to be heated. When it heats, it goes water, SO2 and sulfur, and this got precipitated. I think it makes sense. Yes, it is making sense. So these are the species which you would get. So water, SO2 and sulfur. So what options do we have here in that particular slide? The options do we have? So in the first case we get water, second and fifth is the right statement. We happen to get SO2 as well as sulfur. And in the second statement we said when Ag2SO3 is being heated, metallic silver, that is third option. Metallic silver we get along with SO3, first and third. So this means this also is correct one. And in the C option we happen to get silver sulfide plus SO3. Silver sulfide. Is there any option silver sulfide? Yes, fourth and first. So this means this also is correct. And last option is of this, and you would get metallic silver along with sulfuric acid. So D option is also correct. I think I made my point clear. So hopefully you have got everything rightly. Going on to the next question. This I find is a very interesting question. You are being provided with 3 acid radicals. These are sulfite, thiosulfate and thiocyanate. So these are the three species which are being given to you. Place them correctly in the following sequence of reaction. Oh, interesting. So cyanide is being treated with 1 to give you 2 and 3. And they are referring here that 1 when treated with ferric chloride gives violet color, 2 when treated with ferric chloride gives red color, and 3 on reaction with silver nitrate and on heating gives you metallic silver. So metallic silver type of a thing we just have done with. Few minutes back we already have done, because obviously we would have the options of sulfite. So either I would get this thing, or I may get this thing, because these are the, if you treat silver nitrate with these two anions, you, or even if I would write, these are the three things which we can get, and these two would on heating would give you metallic, this only would on heating gives you metallic silver. So in a way we are getting the feel that third anion should be, or let us check this out, it can be SO3 negative, it can be SO3 negative anyhow. And now we have to see into the ferric chloride. Now ferric chloride has two options to go with. There are two ways to identify this. Ferric chloride in a way is a, you can say, because it is in the +3 oxidation state, it may act as a precipitating reagent at times, just like in detection of sulfur, where thiocyanate is being, if you could recall from the viewpoint of Fe3 positive, SCN negative, if you could recall from the organic qualitative analysis, where sulfur detection is done like this, where ferric chloride is being added to thiocyanate, and this appear as a red coloration, and so that in a way is a precipitating reagent. Other way around is it can act as a, you know, oxidizing agent, but it's a very poor. Fe2 want to go to Fe3 as a reducing agent. So the point here is, but definitely Fe3 positive can act as an oxidizing agent, just like if you treat with metallic zinc. But here is, so what we can get here with. So there are 2-3 things which you have to parallelly, you know, think about. And along with, they are saying that cyanide is being treated with anion 1. So what way we should go? I may think it like this, that if I just would write it here, that cyanide ion, if I would treat cyanide ion with thiocyanate, so what shall I get with? So I may get thiocyanate and SO3 negative. This is the species which I may get, and the reaction is also balanced with. Now the point here is, this on treatment with Fe3 positive definitely would give you what you call it as red coloration, and this on treatment with silver and followed by heating would give you metallic silver. First this precipitate is being formed, SO3, and on heating you would get silver along with SO3. So this also we are clear with. So definitely now the point is, what is the fate if this is directly treated with ferric ions? Then you would get a sort of soluble complex of this type. You would get a soluble complex of this type, which is violet in color, and which easily in the presence of Fe3 positive decomposes to Fe2 positive, giving you tetrathionate ion. This also you should keep it in mind. You happen to get a tetrathionate ion during this reaction, but this is a violet color, and this ferrous ion would, let me show you in the next slide what I am referring to. So this is what I am referring to. So Fe3 positive, and you would get a violet color here, and excess of Fe3 when added, it changes to, because ultimately here this happens to go to this one, where it is acting as an oxidizing agent, and this is acting as an reducing agent, and here this is just acting as a precipitating species or precipitating reagent. So it's a beautiful question where lot many things have been checked. Now let us go into the options, what options they have said about it. So we are almost near to the answer. So this we found it as SO3 2 negative, and 2 is your thiocyanate ion, and this is sulfite ion. So what options they have? Third is so this in a way is a right statement. 1 is, so this also is a correct one. 2 is thiocyanate, this is a wrong one. And second is, so this is correct one. So A, B, D is a right answer. So I find this question to be very, very interesting and important. Moving on to the next problem. So here in this question, this sort of a question we did last time in the last video also, where I talked about the fact that whenever you are being treated with, you are being given zinc as one of the reagent, it primarily be acting as a reducing agent in the presence of acidic medium. And in the basic medium, if zinc is being added, it reduces nitrate to ammonia, if you could recall the last video. So principally this would be acting as a reducing agent. So this salt in a way would have some anion which would have the property of oxidizing. So this is having a oxidizing anion, this salt P. So this you have to keep it in mind. So the point here is, the fellow is asking, thereafter it produces H2S gas, some gas, and that gas on treatment with these precipitating anions gives you yellow PPT, black PPT and colorless. So the point here is, which we may think it like this, that if I have sulfite ion with me, and if you treat it with zinc in the presence of H positive, this we did last time also, it produces H2S, where it happens to go from +4 to -2. And here in the way, you also would see that this particular gas then can give yellow PPT with cadmium sulfite and black PPT with lead sulfate, and this as an when H2S is being treated as an reducing agent with KMnO4, so it turns purple color to Mn2 positive, which is colorless or light pink. So this is what we have to think about it. So the point here is, they are asking which out of salt P cannot be. So I could see that although this is in +5 oxidation state, this is in +6, and this is in +5 oxidation state. All of these are, now this is literally quite important, all of these are oxidizing anions. This is oxidizing, this is oxidizing, rather I would say sulfate and nitrate is a better oxidizing anion, because they are in higher oxidation state, they would want to come down. And zinc, as a metallic zinc, can undergo oxidation to produce Zn2 positive. The point here is, they said this along with some gas is being produced which have this characteristic properties, that it cadmium acetate as a precipitating agent react with that gas and gives you yellow PPT. So from here we may ignore first 3 options, because these would not produce a gas which have the properties which is being shown by these precipitating reagent and this oxidizing agent as KMnO4. So the point here is, the answer to this question would be sulfite ion, because it on reduction gives you H2S. So the point the question is asking, salt P cannot be, because it is asking cannot be, so the answer would be A, B, C. I hope you have understood what I tried to say. Zinc, when treated with these nitrate and sulfate, may reduce them, but they would not produce H2S gas. That is the point which is to be kept in mind. Okay, going forward is the next question. In this particular problem, what is being said about is again a very interesting question, where chlorine, bromine, iodine is being treated with H2S, and sulfur here is in -2. So if you have noticed that most of the time I see every reaction most of the time from the redox point of view, because in a way that gives me a good insight into the inorganic chemistry as well as a whole. In always see any reaction, whether organic, inorganic, from the redox and non-redox point of view. So here the chlorine or halogen is in 0 oxidation state, and we know for sure that halogens are good oxidizing agent. So the point here is, what do we get? So if I talk of SRP, obviously this is a better stronger oxidizing agent as compared to the iodine. As compared to iodine, chlorine is a better oxidizing agent. Okay, fair enough. Now what we can think about, if I just would treat bromine with H2S, so what shall I be getting? 2HBr and sulfur get precipitated like this. So it's a perfect redox reaction, and iodine does the same thing. 2Hi plus sulfur got precipitated. Now the point here is, the important point is of chlorine. Chlorine may do the same thing. Chlorine H2S gives you HCl, 2 moles of HCl and sulfur. But the reaction doesn't stop here. This sulfur in the presence of chlorine, this chlorine being a stronger oxidizing agent, would oxidize it further, just like the way I am showing. It happens to give you sulfuric acid and HCl. What I am trying to say here is, this sulfur, which is in zero oxidation state, happens to go to +6, and in doing so, how many water I should be requiring? This would be 6 then, and hydrogens I need to balance. There are 4, so this would be I think it got balanced. And if I add them together, what shall be the answer I am getting? The answer I shall be getting is chlorine treated with H2S along with 4 moles of water, and the moles of chlorine required are 4, and this gives me sulfuric acid along with 8 HCl, because 6 HCl are formed here, 2 HCl are formed here, so 6 HCl are being formed. So it's a interesting question, where you have to see into the fact that chlorine is behaving as a stronger oxidizing agent. Bromine and iodine do oxidize sulfide to sulfur, but it would not be able to oxidize further to take it to the sulfate ion. So this is a very important question. So what answer do we get here? Element, so we need to see the correct statement. Unlike the previous, in the previous question we have to select the incorrect one. Elemental sulfur is produced in reaction 2 and 3. So 2 and 3, yes, it is perfectly right. Reaction 1 produces sulfuric acid, perfectly right. Maximum production of halogen acid means HX, HCl, HBr or HI, takes place in reaction 1. Okay, reaction 2 and reaction 3 produces sulfuric acid more than reaction 1. No, this is a wrong statement. Sulfuric acid only is being produced in the reaction number 1. Now what, in a sense, more halogen acid? Yes. Now economical is this one. If I would show you once again, H2S, 1 mole of H2S reacted with 4 moles of chlorine. 4 moles of chlorine. So 4 moles of chlorine oxidizes sulfuric acid to form HCl. So 8 moles of HCl is being produced when you use only 1 mole of H2S. In that sense, you may say it as per mole of H2S, more chlorine is being used. So what basically they are asking in the option is, let me check it out what they said. Maximum production of halogen acid takes place in reaction 1. So this is, in a way, is correct, because 1 mole of H2S happen to react with 4 moles of chlorine, which in a way gives you 8 HCl and 1 sulfuric acid. So maximum production of HCl is being produced in the reaction number 1. So the option seems like A, B and C are the correct answers. Okay, so this again was a interesting question. Moving on to the next problem. This seems like easy. Salt P dilute sulfuric acid in rotten egg like smell. As soon as you see the rotten egg like smell, you should know that it must have produced H2S. Very simple it is. And H2S, okay, now the salt must not be. So H2S is being produced if you have a starting material as sulfide. So sulfide, when treated with 2H positive, happens to give you H2S. And as a matter of fact, if you treat sulfide ions with lead acetate, you would get PBS, which is having a black precipitate. But the question is, salt P must not be. So must not be means that A, B and D would be the right answer. So A, B, D. So this you have to see it very carefully that what is being asked and what is to be selected. Moving ahead, next problem came from the topic of uh, okay, so sulfide ion detection. You might have read this particular test is sodium nitroprusside test. This particular species is called as sodium nitroprusside, which on reaction with sulfide ion gives you purple color. So what they are asking, it's a simple question, not a difficult one, but we have to select it carefully. Reaction 1 produces this. I think this is a wrong statement, because when sulfide ion get attached to NO, the formula happens to become Na4, FeCN5, FeCN5, NOS. So here this is generally people will take this out as correct, but here it is wrong. So you need to be little vigilant. So this is a wrong answer, and it must be having, X must be having thionitrite ion, which is perfectly right. This is thionitrite ion, so this seems like correct. Oxidation state of iron is +2. So if I just would mark it here, this is +4, this is -5, this is -1, so this must be +2. Then only the algebraic sum would come out to be 0. So this is also correct. X must be diamagnetic. X must be diamagnetic means that all of these are strong field ligands and there is pairing, and here the iron is in D6 system, 3D6 system, and all of these are strong field ligands, so it would lead to pairing. So 1, 2, 3, 4, 5, 6. Cn negative is a strong field ligand. It will lead to the formation of paired up. It do the pairing up, and as a consequence there is no unpaired electron, so it is diamagnetic. So it seems like everything is correct in this particular. So what options did we find? B, C and D would be the right answers. B, C, D would be the right answers to this particular question. So this is sodium nitroprusside, which when treated with sodium sulfide happens to give you this thing. And as a matter of fact, which you always already I have explained somewhere, that if you treat it with, so this is the anion, and if you treat it with sulfide ion, so what exactly would happen is you would get a species of this nature, isn't it? And this may undergo resonance like this, and this is what you are referring to as when we have said that FeCN5NO, and this is the species which we are talking about. This NO got converted to NOS, which is this species, thionitrite ion, you can say it like that. So it's a quite a important one. Moving ahead, so this question seems like easy. Again a very simple one, sulfide and H2S. Okay, now this is very interesting to, this is again a information based. X, definitely sulfide ion can be detected. X would give the purple or red color, intense color you would obtain with. X is this, here the formula is written correctly, so this is correct. Now what about H2S? Now make it a point, H2S do break to give you sulfide ion, but this is a weak acid, very poorly weak acid, and it would not provide that much of sulfide ions so that this particular reagent would turn purple or intense red. Make it a point. So H2S although provide sulfide ion, but the concentration of sulfide ion given is too less. The sulfide ions are too less to show coloration, by binding it with the complex. So we would be saying, so this is a important information you should know, H2S do not give sodium nitroprusside test and no coloration would be found here. So the answer to this question would be A and C. Again, this is a interesting one, informatic based. Moving ahead, again this seems like a question which take into consideration the flow chart. Salt P treated with AgNO3 gives a precipitate, and excess of salt P gives a clear solution, and you have a black precipitate. So here the best way is to see the options directly, because AgNO3 almost precipitate all the acid radicals. So as long as we don't have acid, because these precipitate on heating gives black precipitate. Black precipitate generally is of sulfide ions. But let me see into it what basically it is being asked. So if you would see A option, if I would mark it here, A option is talking about the sulfide ion, and this also talks about the sulfide ion. So the point is that if I would take, because if I have to start from A or D option, so I may think about two things to happen here. Let me show you it here. So if sulfide ion is there, sulfide ion on reaction with AgNO3 gives you this, which is a precipitate, and which on heating gives you black precipitate. And this we have just few minutes back we have talked about it, that this silver thiosulfate, when is being added with hypo, it gives a clear solution of this particular thing. And had I started with the sulfide ion, I directly would have got this precipitates which are black in color, which on heating would not give you black precipitate. Is it okay? So this would not be decomposable, okay, and nor it would, if I add excess of the salt, it would not solubilize. So the point here is we happen to get thiosulfate ion as to be our answer to this particular problem. So P must be this is perfectly right, and a clear solution contains this is also correct. Precipitates is buff colored, this is wrong. The precipitate which we obtained here is, I should write categorically, these are white precipitates which turns to black because they get attached as in sulfide. So here we would, what other options do we have? So this is wrong, this is wrong. So the answer to this question would be A and B. Moving ahead. In the next question, what is being said about, so this we said few minutes back only, I have spoken about this thing, that any acid radical gives positive test with ferrous sulfate and dilute sulfuric acid to produce a brown color, okay, and salt X, okay. So here is the interesting question. So they said that acid radical X gives a positive test with ferrous sulfate, and so this, when I talk about brown color, so this gives me a information in regard to what you call that as to be what we call it as to be brown ring test. So in the brown ring test, you happen to have two things with you. Brown ring test is being given when you have nitrite or nitrate. Both of these can give you brown ring test, where freshly prepared ferrous sulfate and dilute sulfuric acid are taken, and in the process, in situ, NO gas is being generated, and that NO gas then get attached here as this entity, and this happens to give you brown color. So the point here is, this brown color is being achieved here, and this brown color can be produced from these two. And the second part of the statement, which we have already spoken about, that the salt X on reduction with zinc, this is very important, this is a reducing agent. And I said categorically last time also and this time also, zinc when treated with OH negative, so this reduces nitrate and nitrite to ammonia, and ammonia then decolorizes the Nessler reagent. That is very, very important. So the information they gave here is of about the Nessler reagent. Nessler reagent is HgI4, 2 negative. Ammonia can be detected with the help of Nessler reagent. It decolorizes it and turns it to the brown, which turns the Nessler reagent brown. So it converts it into a brown color. So that is very, very important, which you have to mark it here. So three things have happened together. They are talking about brown ring test. Brown ring test is being shown by nitrate and nitrite, and both of these species on treatment with zinc in alkaline medium or aluminium in alkaline medium converts nitrate and nitrite to ammonia, and that ammonia reacts with Nessler reagent to give you what we call it as a compound which would have which turns the Nessler reagent brown. So this is what is being said about. So what is the answer to this question? A and B would be the answer to this particular problem, because amide and sulfide would not do the thing which is being asked for. Okay, so this I just have spoken about. Reduction of nitrate to ammonia. Reduction of nitrate to ammonia can be done by zinc in alkaline medium or aluminium in alkaline medium. So if it is nitrate or nitrite, it reduces it to ammonia along with the formation of soluble complex of zinc of this nature and that of aluminium. Balancing you can do it yourself, because as such it is not required. Wherever balancing is required, we will do, if the question asks that way, we will do that way. Okay, coming on to the next one. During the detection of nitrate ion in the brown ring test, which other ions, if present, may interfere? So this again is a very interesting question, because in the brown ring test what you require is ferrous sulfate along with sulfuric acid, and of course you are either taking nitrate or nitrite. So if you are detecting nitrate, nitrite would be the interfering thing, and if in the system bromide and iodide are also there, then this sulfuric acid would oxidize them to generate a bromine and iodine, which would have some color. So these would be the interfering ions. So B, C, D would be the right answer to this particular question. Okay, moving ahead. So this is what I was referring to. So these would react with sulfuric acid to give this. This in a way, this particular question I find it very, very interesting. A typical problem which can be asked in the paper. So P salt when treated with silver nitrate gives you a precipitate. So all of these can give precipitate. So this is Ag2S, this is AgBr with silver, this is AgCl, and this is AgI. Now he is saying that precipitate 1 do not dissolve in HCl. So now here the information is that AgI, AgCl, AgBr, Ag2S, all of these would not dissolve in strong acid. This we have discussed 2-3 times in the previous lecture. Previous 2-3 lectures we already have talked about. But definitely these can dissolve in ammonia except for these two. These two would not dissolve in ammonia. So the point here is that what answer do we select here? What answer do we select here? So this is what I am referring to, that these all when put into acid is insoluble. These two when dissolved in ammonia, put into ammonia, is insoluble. So this point you have to keep it in mind. So what answer do we get? Because we have to ignore chloride and bromide because they do form a complex with ammonia. So this and this would be the right answer. So this is a interesting question, A and D. Moving ahead. Gas evolved from which of the following would turn Nessler reagent? So if you want to convert Nessler reagent brown, so you have to produce ammonia gas, and this we have said few minutes back that nitrate can be produced from this. Now what about the C option? When you treat nitrous acid with HCl, what the thing you would get with nitrous acid, and this nitrous acid decomposes to give water, NO and NO2, something like that, and that would have a brown color. So here the point is that this would not produce ammonia, and ammonium ion when taken in an alkaline medium always produces ammonia. So if ammonium ion is treated with strong alkali, so it would turn to water and ammonia. So we are very sure about it that this acid 1 is stronger than acid 2 or acid 2 as a water, and obviously, and OH negative is a stronger base than NH3. So this in a way is also going to produce ammonia. So options would be A, B and D. So this I think we have. Okay, and one more thing which I may have missed in the previous discussion also, that ammonia when reacts with Nessler reagent, this particular compound is being produced, which you should remember, but you should remember it's more of a often the color, that you have to simply remember this thing, that ammonia can be detected by Nessler reagent, because stoichiometry of this reaction is very complex one, so need not to think much about it. So you only have to remember, if you can, this formula and the color. Okay. Moving on to the next question. I think we are done with, and we almost have done, I think we have almost done 10-12 questions in today's session. Hope to see you in the next video, where we now would start with the cation analysis or the basic radicals. In that would not take much time, because that is more systematic. But when you start when the cations are categorized into different groups, thereafter it becomes very complex, that out of that group cation is to be identified, a confirmatory test is to be done with, then it becomes very engaging and tough. Thanks a lot. Have a nice day. Stay safe and take good care of yourself.